Hello students, we know the properties of gaseous state depends upon the factors involved. That means it depends upon the condition that the gas enclosed in the particular container. What are the conditions we are applying for the gas? The properties of gas also depends upon the different parameters. Already we have discussed different gas laws, that is Boyle's law, Charles' law, and their specific condition and relation between different physical properties. So generally the gas which obey the different gas laws are called ideal gas. If they are obeying the properties and following the statement of gas laws, so these are called ideal gas. Ideal gas property, generally it is studied by Maxwell and Boltzmann, specific the properties of ideal gas. So this is called kinetic theory of gas, particularly for the properties of ideal gas. Actually, if you see, no gas is 100% ideal, but it will be ideal in nature. It will obey the gas laws under specific conditions. So what are the properties of ideal gas? Let us discuss what are the features. Gas means ideal gas. Gas consists of very tiny particles called molecules. Very small particles called molecules. And these gas molecules are considered as a spherical elastic bodies. That means spherically elastic bodies. Spherical elastic bodies means just like the properties of elastic substance. And gas molecules moving randomly and undergoing elastic collision with the wall of the container. That means during random motion of gas molecules, because the gas molecules are far away from each other due to some large space between the gas molecules are free, so they are moving haphazardly, randomly. Due to the random motion, they strike on the wall of the container and giving pressure. And this collision with the wall, this is generally elastic nature. Elastic means that velocity it moves after striking, after collision, it returns back with the same velocity. That is elastic collision. But during elastic collision, the energy and momentum of the gas molecules are conserved. Energy is conserved, total energy remains same, and your momentum also conserved. There is no increase or decrease of energy and momentum. Very important factor is there is no force of attraction between the gas molecule. As the gas molecules are free, they have more sufficient space between them, so the force of attraction is negligible. They are moving here and there without attraction. And the actual volume of gas molecule, actual volume means if you bring the gas molecule come closer, that non-compressible volume, if you bring come closer, that non-compressible volume is called that. This actual volume, this non-compressible volume is called actual volume. This actual volume very small compared to the total volume of the gas, that is volume of the container. and this can be neglected in comparison to the total volume of gas. That as the volume of container is very large, very much more compared to the actual volume of gas when it come closer, then it can be neglected in comparison to total volume, because the volume is large compared to the volume of gas. That's why it can be neglected. Gas molecule possess different types of velocity. We will discuss later. It shows different types of velocity, and the velocity also depends upon temperature and other factors. And these velocity are different from one another, and the kinetic energy of the molecules, the kinetic energy, that means average kinetic, that is its average kinetic energy. The average kinetic energy is directly proportional to temperature. If temperature increases, the average kinetic energy of the gas molecule increases. And the gas molecule during collision with the one another or with the wall of the container, they produce pressure. They exert pressure. When they collide with one another or with the wall of the container, they produce pressure. So these are the very important characteristics, that is the features of ideal gas, studied by Maxwell and Boltzmann. This is called kinetic theory of gases. Then let us discuss what is the kinetic gas equation. Kinetic gas equation we will discuss. Kinetic gas equation. Kinetic gas equation, generally it is the relation between pressure, volume with mass of the particles and its velocity. So in kinetic gas equation, this is the relation that PV is equal to 1 by 3 mn c square. What is c square? C square is the velocity. Here c is the root mean square velocity. It is called root mean square velocity. Root mean square velocity means c is equal to, if that n1 number of molecules showing velocity v1, then square, n2 number of molecules showing velocity v2 and its square. Similarly, n3 number of molecules showing velocity v3 and square, like this. Then upon n1 plus n2 plus n3, like this, and its square root. This is called root mean square velocity. You see, root means square root. Square root of square of the velocity and its mean. That means first we have to convert the velocity of each molecule, that velocity, into square form. Then number of gas molecule possessing the particular velocity, let it be v1 for n1 molecules, v2 for n2 molecules. So what will be the total velocity? n1 into v1 square, then n2 into v2 square. Then when the total number of molecules will be divided, then it will be called average. So that is called root mean. Mean means average. Root mean square velocity, that is c. So this derivation n1 v1 square into n2 v2 square, like this, upon n1 plus n2 plus n3, this is called root mean square velocity. You see, root means square root, mean means average, and then s means square, v1 square, v2 square, like this. So this is the called root mean square velocity, symbol is c. So this derivation is the kinetic gas equation formula. PV is equal to 1 by 3 mn c square. Let if n is equal to n0, if a number of molecules will be Avogadro's number, then PV, this equation will be 1 by 3 capital M c square. What is capital M here? Here capital M is the molar mass. that m is equal to molar mass, because when n will be n0, then the mass of particle is small m, then when n0 is multiplied, then into the total mass will be molar mass, because all molar mass contain Avogadro's number of molecules. So when n will be n0, then small will be multiplied, total mass will be molar mass. So PV is equal to 1 by 3 mc square. Then what is the root mean square velocity? C will be, what is the value of C? C will be PV 3PV upon m square. This one. So this root mean square velocity can be written as PRT upon m. Because you know PV is equal to nRT for ideal gas, when n will be 1 mole. N will be 1 mole means Avogadro number of particles, Avogadro's number of molecules. Then PV will be nRT, n will be 1, so 3RT by m. This is the calculation of that root mean square velocity is equal to 3RT by m. Then we know that as PV here, as PV, this is equation 1, remember this one. As PV is equal to 1 by 3 mc square, it can be written as 2 by 3 half mc square. There will be no change because 2 is multiplied and 2 is also divided. So this is equal to 2 upon 3 Ke, that means kinetic energy, half mc square, that is called kinetic energy. Now PV equal to 2 by 3 K imply kinetic energy is equal to 3 by 2 PV, which is equal to 3 by 2 PV is equal to RT. Now this equation, kinetic energy is equal to 3 by 2 RT. If you divide the Avogadro's number, then average kinetic energy, because when you divide Avogadro's number, it will be average, then it will be equal to 3 by 2 R by T upon N0. K becomes average when you divide Avogadro's number, then it 3 by 2, then R by R is a constant, we know universal gas constant, N0 is also constant, related to another constant K into T. What is K? K is equal to universal gas constant, then by N0, and this is called Boltzmann constant. K is called Boltzmann constant. So kinetic energy, average kinetic energy is equal to 3 by 2 kT. K is a constant, 3 by 2 is constant, and then this indicates average kinetic energy is direct proportional temperature. Already we have discussed here that gas molecule possess different types of velocity and its average kinetic energy is directly proportional to the absolute temperature. Now it is proved. This is the average kinetic energy direct proportional temperature using kinetic gas equation. From kinetic gas equation, we proved that average kinetic energy is directly proportional to absolute temperature. So this is the one relation between average kinetic energy of the molecule. This is also important, calculation of kinetic energy. Then PV is equal to 1 by 3 K, and average, this is important, this is your what? Root mean square velocity is equal to 3RT by m. Okay, you write down this one, then we will go forward for regarding the other types of velocity possessed by the molecules. Already we have discussed gas molecule possess different types of velocity. What are the different types of velocity possessed by the gas molecule? What is the relation between them? We will discuss now. Okay, let me clean the board. Okay, you finish this one. Gas molecules have different types of velocity. They are moving in the container with different velocity, and this velocity varies with temperature, with the size of particles. So let us discuss what are the different types of velocity possessed by the gas molecules. Generally, there are three types of velocity. First one already we discussed, that is root mean square velocity. Root mean square velocity already we have calculated, that is C is equal to square root of 3RT by M. This is your root mean square velocity, 3RT by M. Already calculated. What is root mean square velocity? This is expression is like this, that if n1 number of molecules showing velocity v1 square, v1 and square, n2 number of molecules showing the velocity v2 and its square, n3 number of molecules showing velocity v3 square, like this, upon n1 plus n2 plus n3, like this square. This is the root mean square velocity of the gas molecule. Another type of expression, that average velocity. Average velocity, that is mean velocity. That symbol is C bar, which is equal to, if you see, that is calculation, it will be 8 RT by 8 RT bar per M. That is square root. 8 RT bar per M. What is the average velocity? 8 RT by per M, and this expression is like this. N1 number of molecules showing velocity v1, N2 number of molecules showing velocity v2, N3 number of molecules showing velocity v3, like this, upon average means N1 plus N2 plus N3, like this. So this is the calculation of what? Average velocity. Average velocity is equal to 80 RT by pi m. Then if you see third velocity, that is most probable velocity. Most probable velocity. Most probable velocity, that symbol is C star, which is equal to 2 RT by M. 2 RT by M square. RT by M. Okay, this is the most probable velocity. What is the meaning of most probable velocity? Most probable velocity means maximum number of molecules, that is the maximum fraction of molecules showing this velocity. Its meaning is maximum fraction of molecules showing this velocity, that is called most probable velocity. So if you draw a graph, suppose this is your velocity, this is your fraction of number of molecules showing velocity, fraction number of molecules showing velocity. If you draw a graph like this, in the graph, top position, this graph, you see This is the point where maximum number of molecules, maximum fraction showing this velocity. This point is C star, that is most probable velocity. And this graph, if you come to this point, this is your C bar, average velocity, and this is your C, root mean square velocity. So this is the diagrammatically representation of three types of velocity. Most probable velocity, the number of particles is more, then average velocity, number of particles is less, then root mean square velocity, number of particles will be again less. So if number of particles, if you consider number of particles showing C star will be less than number of particles showing C bar, less than and number of particles showing root mean square velocity. This is the relation. Number of particles, number of particles C star will be more, this is the greater than this one, because you see number of particles C star is greater then C bar, then C. So, but if you see the velocity graph, x-axis, so which is more? C is more. But if you see, C is greater than C bar, greater than C star. This is very important. This relation indicates the number of particles showing different velocity, and this relation indicates the velocity relation between that root mean square velocity, average velocity and most probable velocity. Already expression we have discussed. Average means total velocity upon total number of molecules, and root mean square velocity already like this. That is square of the mean of the root of the square of the mean. You will get the root mean square velocity. Most probable velocity, that means the fraction of molecule which has maximum fraction of molecules showing that velocity is called most probable velocity. But don't be confused that most probable velocity is the maximum velocity. No, this is the least velocity. Velocity if calculate, C star will be minimum. So this is the expression. But if you compare the relation that which is the lowest, C star is the lowest, so this is the 1:2, that is if you write like this, C star is to C bar is to C, if you compare. So the relation is C star is 1 is to C bar is 1 point how much? 1.128 is to 1.224. You see the relation, that ratio of most probable velocity with average velocity with root mean square velocity, the relation is 1 is to 1.28 is to 1.224. So this is the important relation. This is also important relation. Okay. Then these are the three types of velocity. But if you draw another graph, that this is related to temperature, this is your fraction of molecules showing velocity. If you draw, so this is the one graph. This will be another graph, and this will be another graph, and this graph indicate the most probable velocity at temperature T1. Okay, and this is the velocity, most probable velocity C star at temperature let will be T2, and this is the another most probable velocity at temperature T3. So if you see the graph, that velocity, this is the temperature, sorry, this is the velocity, this is not temperature, this is the velocity, this is the velocity versus del by n. For the particular gas, if the temperature, you see, suppose when temperature increases, then what happens? The CT3 will be greater than CT2 is greater than CT1. What does it mean? Velocity is increasing. When temperature increases, velocity increases, but the fraction of molecules, but you see the fraction of molecules decreases. The velocity increases, but the particular fraction of molecules, their velocity will be decreased. But when T increases, the particular most probable velocity will be more. So this is the relation between that different temperature at different temperature with velocity. When temperature increases, the velocity, the most probable velocity also increases, but the fraction of number of molecules, the velocity decreases. So this is the relation between what? The different types of most probable velocity at different temperature. Then let us discuss one problem. The problem is like this, that let it be oxygen gas. This is for like oxygen gas. Question at what temperature? At what temperature the average velocity, of oxygen is equal to the root mean square velocity at 27 degrees Celsius. This is the question. One question related to the formula. A question is at what temperature the average velocity of oxygen gas is equal to its root mean square velocity at 27 degrees Celsius. So if you see the formula, answer like this. So what is the relation between that average velocity? Average velocity is 8 RT by pi m. So C average is equal to 8 RT by pi m square root. What is the root mean square velocity? Root mean square velocity is equal to 3 RT by m. Root mean square velocity is equal to 3 RT by m. You have to remember, very important is formula. You have to remember all formula related to the particular chapters. Then you can calculate, you can solve the problem using direct formula, and you have to know the use of parameters, different values, where you will use. Average velocity is 80 RT by pi m and root mean square velocity is equal to 3 RT by m. But as per the question, average velocity is equal to root mean square velocity. That means 8 RT by pi m the square root is equal to 3 RT by m square root as per the question. But in the question, the velocity, RMS velocity are 27 degrees Celsius. So average is this one. So 8 RT by pi m is equal to square root is cancelled. So 3 RT, here 3 RT is your, that which one? Average velocity. Sorry, 8 RT by pi m, that is your average velocity. So average velocity is temperature, and 3 RTM is equal to root mean square velocity. So T value is given at almost 300 degrees. Because 27 degrees Celsius is equal to how much? 300 Kelvin. So by M. So M part is cancelled because it was same oxygen gas. R part is cancelled. Okay. Then T will be calculated. So value of T is equal to, if you put this value, 3 into 300 into how much? Into pi by 8. Pi value is 3.14, that is 3.14. So 900 into 3.14, 1.414 upon 8. If you calculate, then T will be how much? T will be how much? Calculate. You calculate quickly. Here result approximately, that is 27 bar, that is 4.5 means 4 point something. So that is 27, around 2800. So result is how much? Result is how much? 353. Result will be 353. How much? 353.5 Kelvin. This is the temperature. So 3 at T by M, 8 at T by pi M. So M is cancelled. So result is T value will be 900 into pi is 3.414. Then by 8. Result is how much? 353.5. So in degrees Celsius is equal to, if you deduct from 273, result is 80.5 degree Celsius. So this is the answer of the question, that the temperature at 80.5 degree Celsius, the RMS velocity of oxygen at 27 degree Celsius is equal to its average velocity. So question is, that means at 80.5 degree Celsius, the average velocity of oxygen is equal to its RMS velocity at 27 degree Celsius. That means when the temperature will be differ, that means different velocity, the gas shows different velocity at a different temperature. When temperature will be changed, these three types of velocity will differ. So this is one important calculation in relation to two types of velocity, that is average velocity and root mean square velocity. You practice more, then you can understand the different types of problem. Okay, so any doubt you have, you can interact with me. Okay, thank you.